some interesting figures in the coordinate plane and ask if one figure is congruent to another figure, if one figure is similar to another figure, meaning they have the same shape and whatnot, and how can we get from one figure to another, meaning how can we actually transform? What transformations can we apply to one figure to make it actually become another figure? So I want to take a look at a couple of examples together and have some fun. So here's the first one I want to take a look at, and you can see here I've got a square, a 2 by 2 square, located here, center of the origin, and then here I have a 1, 2, 3, 4 by 4 square that's kind of off to the side. This one's called A, this one's called B, and our challenge is to identify a sequence of transformations that will transform figure A into figure B. Okay, well, how might we do this? Well, the first thing I notice is that this A is kind of small. So the one thing I want to do is actually kind of enlarge it. Well, this length is 2, this length we see is 4, so actually I need to dilate. I have to give a dilation with a scale factor of 2, which means that if I just took this length and multiplied it by 2, that's what the scale factor of 2 means, it would take 2 multiplied by 2 becomes 4. So in fact now it would kind of be twice as long and twice as high, so it would be the same size as this. Since this one's smaller, I see that these two are not congruent, but once I put on a dilation with a scale factor of 2, then I can actually move this over and up, and I see they match up perfectly. In fact, let me actually illustrate that up there. Now watch it. You see, first I'm going to dilate it by a scale factor of 2. You see how it kind of puffed up? Now I'm going to slide it a little bit over to the right, and now a little bit up, and they match up perfectly. That means that the original shape A and B were actually similar. So they're similar. That's awesome. And now, what about the translation involved? Well, the translation, let's look at the center point. The center point here has to get moved to the center point here. That means I got to translate it in the x direction, 6 over, and then in the y direction, 2 up. And so I can summarize all of this with the following little summary. Shape and orientation, we see that these two things have the same shape, which means that they are, in fact, similar, but they are not, in fact, congruent because they're not the same size. They have the same orientation because they're both squares that are sitting nicely perpendicular and parallel to the axes. The size, well, the length of sides of B are 2 times the lengths of sides of A, so we see this is twice as long as that, so there's a scale factor of 2. And then the location, well, to get from A to B, we take every single x value and we add 6 to it. That's what we saw here. 1, 2, 3, 4, 5, 6. There we go. And then now 2 up. 1, 2. So if we just take this and we add 6 to every point here, that moves it to here, and then raise it by 2, it fits in perfectly. So that's actually the way to translate the A to make it look like B. And then we have to scale it up, and then we've got it. So that's excellent. Okay, great. So there's that. Now let's take a look at another example where we can actually see a more interesting, more well-rounded, if you will, example. So let's take a look at this one. So here we have 2 shapes, and I want to identify a sequence that will transform figure C to figure D. This kind of looks like a circle that has something missing, like a pie where someone took off a quarter piece. And this is similar, a little smaller circle with again, a quarter piece removed. So that tells me these are actually going to probably be similar. But let's take a look and see if we can verify that for ourselves. The first thing I might do is notice that I could take a reflection of C over the y-axis. And I'm going to do that up there. Check it out. Watch what happens with the C. You see how it just kind of rotated and reflected itself around the y-axis up there? So now you see that the bite removed is kind of in the same location in the northeastern corner. Now, all I have to do is consider a scale factor. Well, see, this circle has radius 1, this circle has radius 2, so I've got to scale C down by a scale factor of 1/2. So I've got to consider a dilation by a scale factor of 1/2. That's going to make things smaller. Check it out there. It's shrunk down. And all I have to do now is move them in place by taking C and move it over 4 units over in the left direction, -4 units, 4 units up. And then we see, as you see it up there, they coincide, which means that these 2 shapes are in fact similar, but they're not congruent because they're not the same size. And so what do we conclude? Well, we conclude here, I'll summarize it. These are the same shape, but different orientation because they're oriented differently. Here the bite mark or the quarter is missing in the northeastern piece, and here it's the northwestern piece. So we had to look at a reflection, and then we had to scale. The size, well, the length of the radii of D are half as long as the lengths of the radii in the original figure. So that means the scale factor is a half. And then the location, well, we've already said this. We take the x values and we move them to the left 4. That means x minus 4. 1, 2, 2, 4. So there's the negative 4, and then up 4, 2, 4. And then we get there. So there we see that. Now, I want us to look at the exact same example again, but see that there's other ways of getting from C to D without just reflecting it. That's one way, but there are lots of answers. Let's take a look at one more. So I'm going to start all over again, and now what I'm going to do is I'm going to take C, and I'm going to now rotate it clockwise by 90 degrees. So that bite mark will now be rotated. Check it out. So now I'm rotating it by 90 degrees, and now I still have to consider a dilation with a scale factor of a half, and then when I slide it over, negative 4 in the x direction, positive 4 in the y direction, we see that, in fact, we win. So we get the exact same conclusion, but we see different ways of getting there. There's not always just one unique way of showing that two objects are, in fact, similar. There might be lots of ways of actually transforming one object to another. So we see that we can look at different geometric shapes in the coordinate plane. Sometimes they're actually congruent. Sometimes they're merely similar. But quite often we can take a look at two shapes and see if there is a sequence of transformations that will actually transform one shape to another shape. By the way, if there is such a sequence, then in fact we know that the two shapes in question were in fact similar. Fun looking at geometric shapes. Enjoy looking at the shapes around you. I'll see you soon.